Okay, guys, how you doing? Coach Scott, War Lewis dot structures. So let's look at some samples. Follow our little rules, right? Rule number one: find the central atom. Let's look at SO3. All right, let's go ahead. There we go. All right, our central atom here would be sulfur. Go put it in. All right, so sulfur is in. Let's see here. Sulfur is in group 16. So it has 6 valence shell electrons. So that's going to be 6. There's only one of those. Oxygen, there are 3 of those, SO3. So that means there are going to be 6. It's in group 16 also, or a total of 18 electrons, valence electrons for oxygen. Add these up, I've got 24 valence shell electrons. So first, I'm going to put my oxygens around everywhere, around the sulfur. O, O. Now I'm going to make single bonds. All right. And I'm going to add all these valence shell electrons. So let's see, I've got 8 there, 8 there, and 8 there. That's 24. Got 8 around oxygen. Ooh, that's not good. So let's see. We need to have 8. So let's take that pair and put it right there. So that oxygen has 8. That has 8. That has 8. And now sulfur has 8. Okay, I'll redraw it. Sulfur, oxygen, 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 dot, 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 4, 5, 6. Okay, so there's 8 there, 8 there, 8 there, 8 there, and then sulfur has 8. So we're happy. Okay, that's 24. The octet rule has been fulfilled. All right, and around A and oxygen, I have 1 double bond, 2 single bonds. So let's clean that up a little bit. Double bond, single bond, single bond. Oxygen, oxygen, oxygen. Lone pairs. Okay, so everything's happy. I've got 8 there, I've got 8 there, 8 there, 8 there, total of 24. Here's my question for you. So you can see that one. Does it matter that it's that oxygen? Could it be that oxygen that has the double pair? It could. So this is what we would call a resonant structure. It doesn't matter which one it goes to. So really, if I was doing a test, I would do my structure like this. Double pair there. So that's called a resonance structure. It resonates in between the bonds. Okay, it doesn't matter which oxygen it goes to. So that double bond would move around a little bit. It's resonance. It shows resonance. And that's one way of showing it. All right, there's a couple of different ways. I'm sure you'll learn some more later. Okay. So, due to the nature of really that D particle, anything in group period 3 higher can't have more than an octet. We looked at one of our examples earlier, okay? The SF4, all right? That sulfur could have a lone pair by itself. Let's look at one of the polyatomics. Now, like I said in a previous video, polyatomic ions are molecules that have a ionic character, okay, or they can be ionic in nature. They can be used to, because it's either got an extra electron or not enough electrons for the protons, all right, due to the skeletal nature of it, okay, and the charge, it can then electrostatically, all right, have that full negative charge, that full polarity, and act like a ion in an ionic compound. Let's look at carbonate, one of my favorite ones. All right, CO3, and if you look at the chart, that has a 2 minus charge. A 2 minus charge. Okay, so carbon has 4 electrons. We're going to get the total number of electrons we got to deal with. And we have 1 carbon, so we have a total of 4 carbons. We'll use green. Oxygen, group 16, 6 electrons. We have 3 of those. So 6 times 3 is 18. Now we have 2 minus electrons, okay? So we have 2 electrons that are part of this molecule. So I'm going to put E minus. Let's use red for electrons. E minus, which is shorthand for electrons. So we have 2 of those. 1 times 2. And just to make it look neat. So we have 2 extra electrons in this polyatomic ion. So let's add these up. 6 and 8. So we have 24 total electrons in this CO3. All right, so our central atom there would be carbon. And then we have 3 oxygens around it. And of course, we want to draw some electrons. So let's put 2 electrons there, 2 electrons there. Do them there, 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 there. Make an octet around the oxygens. All right, so I have 8 there, 8 there, 8 there. That's 24. Well, that's cool, but I don't have electrons around the carbon. All right, I need to have that. I need to have 8 electrons. Got to do something for that. So if I can take this, and I will, and I put those there, okay, and I have a double bond here, that means I have 8 there, I've got 8 there, those 2, or those 4, and these 2, these 4, that makes 8. 8 there and 8 there. That's a resonance structure. So let's see what we have. And I'll clean it up. So let's see. Carbon. double bond, which of course this does show resonance also. Oxygen, oxygen, oxygen. Puts electrons. 2 there, 2 there. 6 around that one. 6 around that one. So let's see. Do we have 8 around everything? Let's check. There's 8. There's 8. There's 8. And there's 8. So we've met the octet rule. Of course, this will have resonance. Do we have our 24? We do. Okay. We do. But let's see why this is 2 minus. Oxygen, okay. Oxygen has 16. We'll check on that. Oxygen has 8 protons. I've got 3 of those. Or 24. Carbon has 6 protons. Times 1. Or 30. Electrons. Oxygen has 8 total, or 24. Carbon has 6 electrons times 1, or that's 6, so 30. And then there's a 2 minus charge to it, so it has 2 extra electrons. "32 total electrons." And if you look at these and you add all the electrons up, this would have 32 electrons. And this is how we draw the structure. All right. Of course, it would show resonance. I'd throw the 3 structures with an arrow in between it, going both ways. So this is how we draw this. And this carbonate polyatomic, we would take this and we could use it in an ionic formula because it has a -2 charge. And we can use it, okay? We can use it in an ionic bond. It'd be ionically bonded to a cation or a positive ion, like calcium, which has got a +2 charge. Calcium carbonate would have 1 calcium. All right. It'd have a 1-to-1 ratio to the carbonates. Okay. And this molecule is a discrete being, a discrete particle. All right. And on a 1-to-1 ratio, it would form a crystal with the calcium. Another name for that would be marble. Okay. So anyway, there we go on that, and I'm going to stop with this. And so this is how you draw Lewis structures. And I'm sure there'll be questions, and I'll look at some in a minute, and we'll draw some examples from your problem, which I just did there. A couple of these were examples from your homework or your pre-work or your summer work. And I can do more if you'd like. Anyway, this is Coach Scott saying have a great day, and hullabaloo, connect.